Hello, everyone, and welcome back to the Boost Your Biology podcast. Today's special guest received a Ph.D. in biology from the Weizmann Institute of Science and completed his postdoctoral fellowship at MIT before going on to found InsideTracker. InsideTracker was founded in 2009 by top scientists from acclaimed universities in the fields of aging, genetics, and biology. And InsideTracker is truly a personalized platform and performance system. Dr. Gil Blander, welcome to the show.
It's a pleasure, Lucas.
Awesome. So, Dr. Gil Blander, did you maybe want to let my listeners know a little bit more about yourself and maybe how your journey unfolded?
Sure. So as you mentioned, I'm Israeli in background, born and raised there. And from a very young age, I was fascinated by the aging process. I wanted to live forever. I wanted to delay the onset of aging-related diseases. I want to improve the health span, not only the lifespan. And that's why I decided to study biology. As you said, I done my Ph.D. at the Weizmann Institute of Science. At that time, I studied premature aging syndrome called Werner syndrome, which is a kind of progeria. Actually, it's a very rare disease, mainly in Japanese population, 1 in 8 million. And what happened to those poor patients is that at the age of around 20, they're starting to decay fast, and they are dying at the age of 40 or so from premature aging syndrome, so graying of the hair, cancer, and so on. So I researched this syndrome during my PhD study, and then I moved to the lab of Lenny Guarente, which is one of the leaders of aging research. As you said, he is located at the MIT here in Boston. And I studied a group of protein or group of genes that call SIR2 or SIRT1 or SIRT1 to 7. And those group of genes have been shown to be related to longevity. Lenny discovered that the SIR2, which is the homologue in yeast, have been shown to increase lifespan when you overexpress it, and a premature age when you delete it. This lab also showed that when you look at the homologue of the SIR2 in worms, you see a similar effect. Lenny and others showed that actually in some mice, you can see an effect of the SIR2 family. A former postdoc in that lab, David Sinclair, which now is very famous, so I assume that all of your listeners know about him, showed that the activator of SIR2 or activator of SIRT1, which is the homologue of human in mice, have been shown to increase the lifespan of obese mice. Another former postdoctoral fellow at the lab showed that overexpressing of SIRT1 in the brain increased lifespan. Other people showed that another homologue of SIR2 is called SIRT6. It's basically the 6 homologues. There are 7 in this family, have been shown to increase lifespan in mice. So there is a lot of interesting data about SIR2 and the longevity in mice and in other model organisms. So I studied this protein for a few years. I looked at the effect of this protein on skin differentiation, on skin aging. I was trying to find a activator or inhibitors of this protein. I also looked at the effect of this protein on cancer and actually found interesting discovery that actually this protein might be a tumor suppressor, a gene basically inhibit cancer. But during my time at MIT, I started to be exposed to the biotech pharmaceutical industry via Lenny and others. And I realized that I might be able to contribute more to humanity for start my own company than being a professor in academia. And I decided after 5 years at MIT to move to the industry. I worked in a system computational biology company. And during my spare time, I decided to build a model of caloric restriction. And I assume that your audience know what is caloric restriction, correct?
Of course, yeah.
So basically what I've done, I said, let's collect all the publicly available data of caloric restriction and look at basically microarray data. And microarrays basically look at all the genome-wide changes of gene expression in caloric restricted mice versus normal mice. And I looked at different tissues, liver and muscle and the brain and heart and other, and tried to build a model and see what are the processes that the caloric restriction regulated. Because at that time, even a bit right now, not everything clear about why caloric restriction extend lifespan. So I developed that model and I found around 18 different processes that are actually changes if you compare caloric restricted mice to normal mice. Luckily, I also added a couple of control. And one control was to take the data from a David Sinclair paper about the effect of resveratrol on obese mice and try to see what is the overlap between caloric restricted mice and basically mice who were treated with resveratrol. And to my surprise, what I've seen is that only 10% of processes that are regulated by caloric restriction were also regulated by a treatment with resveratrol. Wow. So that was a bit of a puzzling result because I was sure that it will cover everything. And I researched a bit about that and then came to a conclusion together with a couple of other scientists that if the best mimetic, at that time that was the best mimetic, can mimic caloric restriction only in 10%. So the second best may be covered 9%, the next one 8%, 7%. So we calculated that you might need 20 small molecules in order to cover the caloric restriction in a good way. And then we said, okay, but why to use a small molecule? Why can't we use food as a drug of choice? We have 8,000 different food items, and we can actually try to fit the right food item for the right person based on what's happening inside their body, and then try to optimize them. And if we'll optimize them, hopefully we'll allow them to be better, but also to live better, longer life. So we said, okay, but how would we know what are the issues that Lucas have versus what are the issues that Gil have? It's very hard to look at you and say, hey, you have this issue or that issue. So we very early zoomed into blood biomarkers because blood biomarkers are like a liquid gold, actually. We have a lot of data about them from the peer-reviewed scientific publication. We have more than a century of data about what are the cause and effect, what are the ranges, what are the interventions that you can use in order to optimize them. So we said, okay, let's look at blood biomarkers, and based on that, we'll try to build a personalized plan for each person of what to do in order to optimize themselves. So then we looked into a Quest diagnostic catalog. Quest Diagnostic is the biggest diagnostic company in the US. And we realized that there are around 4,000 at that time, around 4,000 different blood biomarkers. So we said, we cannot test all of them. It will be super expensive, but also you might not have enough blood in your vein to test all of those markers. So we spent a few years in pinpoint the biomarkers that are the most important for us to test. And we came with a few criteria. So first, it should be biomarker of health and not a disease. So basically, I don't want to test biomarker that will tell me whether you have cancer or not, because that's not my job. That's the job of the physician. But I want to look at markers that tell me whether you have a good metabolism or bad metabolism, whether you over-exercise or under-exercise, whether you are stressed or not stressed, and so on. So we said that's the first criteria. The second criteria was that we really wanted to optimize those biomarkers with a simple and natural intervention. So we didn't want to use drugs. So we said, can we modulate those biomarkers with food, supplement, exercise, or lifestyle changes? And the last one was, let's look at the biomarker that at least 1% of the population is out of normal. Because I felt like it will be a bit of a waste of money for a marker that only 1 in a million have an issue with. So based on that, today we have around 45 blood biomarkers that fit all of those criteria. Then when we had that, we said, okay, now we need to build a range for each of them. So I assume that you know, and your audience know, when you go to your physician, you receive a result and they are telling you whether you are normal or out of normal. But we said normal is not enough. Normal is boring. Normal is not exciting. We want to be optimal, especially you and your audience as a health. We want to be optimal. We want to be in our best. So we develop an optimal zone for each person based on your age and gender and ethnicity and athletic activity. We develop an optimal zone for you based on the data from a peer-reviewed scientific publication And also based on a mega database that we have. And actually now we have a lot of users. I always joke in saying that we have the biggest database of free-range humans that have blood, DNA, and fitness tracker. So we have a very nice database. We can discuss it a bit later. So based on all of that, we can develop an optimal zone for you, that it's a bit narrower. So if the normal zone is like that, your optimal zone is like that. So it's a bit more narrower than a normal zone, and allow you to fight harder and get into the optimal zone. And hopefully if you stay in the optimal zone, there is a less chance that you will be out of the normal range and less chance that you will be sick.
Yeah.
So that's another thing that we built. And then for the intervention, we said all the intervention that we are recommending to our users should be based on a peer-reviewed scientific publication. So we mine the literature again. We spent a lot of years, and actually now I have a team of scientists that continue to mine the literature. And we are entering all of this data into an expert system that basically look into the information that you will receive from you as a user, your demographic information, your athletic activity, your goals, your food preferences, your supplementation, and all of that run in combination to the blood biomarkers that are not optimized, and your DNA and the data from your fitness tracker. And this platform spit out the best recommendation for you based on all of that information. Mm. So that's in a nutshell the platform, my background and the platform that we built.
Yeah, incredible stuff. I got so many questions. The first one, Gil, would be, I would love to uncover maybe some of these markers with my listeners, maybe three or so that you think are like absolutely critical and that have the strongest degree of evidence. Maybe do you want to explore some of those?
Yeah. So from what I understood, you are really interested in hormones, correct? So we can discuss those maybe. Sure. So you have testosterone. I'm sure that you and your audience, they know them very well. So testosterone is very important for sexual function, but also for building muscle. And actually, some people or some athletes are exercising too much, and then the testosterone going down. So what is interesting about testosterone, if you are not exercising, your testosterone will be lower than your potential. If you're exercising too much, it will be also lower. But if you find the right zone, it will be in the peak performance. Also, testosterone is influenced, and I'm sure that I'm not telling you any new information. It's influenced by your sleep, it's influenced by your nutrition, and it's influenced by your stress. So there are a lot of things that influence the testosterone. So that's an example of a marker that we are testing. In the other side, another very important hormone, and I'm sure that you and your audience know a lot about that, is cortisol, the stress hormone. Yeah. So if testosterone is anabolic, building muscle, cortisol is breaking muscle. And when we are stressed, and in the last couple of years we had COVID and all of that, a lot of us become stressed. So when cortisol is high, and especially chronic high cortisol, actually that's causes breaking muscle, and the people that are trying to exercise and build muscle, it's very hard for them to do that. Another marker, interesting marker that's important for athletic active population is a marker called creatine kinase, which is a marker of muscle damage. And when we exercise, or when we exercise too much, the creatine kinase can leak from the muscle to the bloodstream. And I can give you an example. For a normal person, the normal range is, let's say, below 200 units per liter. Someone that ran marathon and ran it and got a lot of muscle damage, creatine kinase can jump to 15,000. So you can see a very not nice, but very big increase in the level of creatine kinase. And what that signal that you had a lot of muscle damage. So that's a marker that is good to test to find whether you have an issue with, and then you can intervene and improve it. And other interesting markers are all the marker of a liver function. I don't know if you and your audience heard about them, ALT, AST, GGT. Those are markers actually of liver damage, but some of them can be also related to muscle damage. Yeah. So ALT and AST are also located in the muscle. So if you have ALT and AST together with creatine kinase, that means that you have muscle damage. If you have them together with GGT without creatine kinase, that means that you have liver damage. Okay, so we're starting to look into combination. And liver damage can occur from a lot of reasons. One reason is that you drink too much alcohol, and then you have liver damage. Another reason is that you eat too much fat. Another one that you eat too much. Another reason is that you're taking too many drugs or too many supplements. So there are a lot of reasons why you can have liver damage, and liver is so important. So it's very important for us to know whether you have liver damage or not. And with the combination, you can start pinpoint the issues. Another important markers are the inflammation. And we learn more and more that inflammation is maybe one of the most important cause of aging. And if you have high inflammation, you have less chance to have a long lifespan and long health span. And we have maybe around 10 different markers related to inflammation to try to pinpoint inflammation. Another set of markers are markers of iron metabolism. And it's very important to have it because iron helps to build the hemoglobin that build the part of the red blood cells that carry oxygen from our lungs to muscle and brain. And if you don't have enough of that, you compromise your performance either on the podium or in the boardroom. So those are a few examples of markers that we are testing and allowing our users to understand and pinpoint the issues that they have. And then we can give them some specific recommendation what to do in order to optimize their body.
Yeah, incredible. Since you mentioned some of the inflammatory markers, Gil, I'm curious to know, like, post-virus, we don't have to mention the word, not everyone knows. What have you seen, like, in terms of how it shows up on someone's blood work? Have you noticed like general patterns? Maybe certain white cell markers have been skewed even weeks after the virus, or inflammatory markers? Like, what have you found?
Yeah, definitely. When you have, it's well known that when you have an infection, one of the best markers for inflammation called HSCRP, or high sensitivity C-reactive protein, you definitely can see it. I have it for myself. A few years ago, I had an infection and I went to test it. So my HSCRP jumped from a level of below 1 to level of 10. So it's well known that HSCRP is increasing significantly when you have an infection. And then you have what we call the white blood cells. So it's a lot of different kind of cells. Basically, it's all the immune cells. So when you have an infection, your white blood cells as a whole increase significantly, but depending on the kind of infection that you have, a specific subpopulation can go up, lymphocytes, eosinophils, and other. And then based on that, you can pinpoint exactly what kind of immune issue you have. So that's what's nice about, again, InsideTracker, that we are looking at the multifactorial issues. And we are looking, as I said, around 45 blood biomarkers that allow us to pinpoint exactly what are the issues that you have. Hopefully, there are small issues. And then based on that, we can give you a plan of exactly what you should do. And hopefully, that will help you to optimize your body and keep the doctor away from you for at least another year.
Yeah. And as far as some of the interventions, Gil, like I know you mentioned, one that's got probably the strongest level of evidence would be that caloric restriction. Maybe do you want to sort of expand upon that? Like, how is that defined? Is that just sitting just below your basal metabolic needs, or like how is that defined?
Yeah, that's a very good question. And I think that we can discuss it for 24 hours at least. But maybe I will give a bit of background on caloric restriction, if it's okay.
Yeah.
So caloric restriction was actually discovered in the 1930s. So a scientist done an experiment on rats and basically cut their calories by 30 to 50%. And what you have seen that those rats lived actually 30 to 50% longer. Okay. Then a lot of other scientists done this experiment with rats and mice, and they've seen similar results. Recently, even some experiments were done in worms and yeast and fish and even monkeys. There is data on monkeys. The majority of the data on monkeys showing that it's extend lifespan. Actually, there is one experiment that doesn't show it, but we are not sure if it's an artifact of the experiment or not. But at high level, you can see that in majority of model organisms, caloric restriction extend the lifespan. Now, there are a few different methods that you can do caloric restriction, and I'm still talking about mice. Let's keep mice for a while. So if you're thinking as a scientist, you usually grow mice in a cage of, let's say, 4 to 5 mice in a cage. And what you do is you feed them ad libitum, meaning you throw a lot of food in the cage, and then they eat it, and every day the technician come and give them more food. So it's like, let's say that it's like when you go to, I don't know if you have a Chinese restaurant buffet in Australia, but it's something like that. You sit in a buffet, and you eat and eat and eat and eat and eat and eat, and you get like you become very fat. So that's how how traditionally mice are fed in the lab. So when you do caloric restriction, you need to start feeding them and measure the amount of food that you feed them. So first, what you need to do is, instead of growing them in a group, you need to grow each of them separately, because you need to know exactly how much each mice ate. So instead of having for each 4 or 5 mice 1 cage, you have 5 cages, okay? Then you need to go down every day and give them and measure the food and give it to each mice. So that's a lot of laborious work. It's very hard. It's time consuming. Think about that over the weekend, you need to come and calculate it and feed them. So it's not easy to do. It's very expensive. So in the past, one scientist said, usually scientists are also creative. So he said, what will happen if I will feed them every other day? So feed them ad libitum, but give them the food, and then the next day they won't have food, and the day after I'll give them the food again, okay? And then he compared the result of that experiment to a result that you feed each mice and all of that, and what they found that actually the effects are similar. So that started, if you translate to the human, it's fasting every other day. So you eat one day as much as you want, and the other day you eat less. Then we started to have, let's eat as much as we want 4 days, and then 1 day fasting, or let's have intermittent fasting. So let's eat, have the window of 8 hours of feeding and 16 hours of fasting. So that's the translation of, let's say, the caloric restriction for mice to human. Now, if you look at human, what the data show, so first of all, it's very hard to see or to know if it's extend lifespan in human, because we live too long. We can do that, but we might know the result in 50 years. So what we are doing with human, we are looking at markers of longevity. So level of lipids, level of glucose or other metabolite, level of blood pressure and other. And the data show that actually when you caloric restrict or intermittent fast human, you see that those markers on average become better. Another outcome of caloric restriction and also intermittent fasting is that you lose weight. And there is a lot of data in the literature that show that people with lower BMI have a better performance and have a better chance to be healthier and live longer. So in addition to that, if you think about an additional effect of caloric restriction, is that when you eat, let's say intermittent fasting, and you eat only in a window, you have more time for your digestive system and your body to rest and not to work all the time. If you think about it, the day that you eat before you go to sleep, your gut is working hard and your quality of sleep is lower. But if you, let's say, eat a few hours before, it's easier for you to fall asleep and you also sleep better. Also, it's allow you to rejuvenate your body when you have that time that you caloric restrict your body. So there is a lot of data that suggests that caloric restriction is working. I want to say that there are some data in the literature that show actually that caloric restriction, or let's say intermittent fasting, working better in males than females on average. So for males, it's easier if you look at markers such as BMI or weight. And it doesn't work for everyone. So some people it's working for them well, some people it's not. And I'm not sure that we know exactly why. Also, I want to recommend someone that is a super athletic active to do caloric restriction and go for a marathon run. No, you need to feed yourself for a marathon run, because if not, you will digest your muscles, because your body needs some energy source. So I think that people need to be a bit more aware of that. And also the data from the literature actually show that if you look at model organism, that even if you start caloric restriction in an older age, you see the benefit. So it's not like you need to start it at a very early age. It's better to start it at a very early age, but you don't have to. Also, it's not like you need to do it every day. And if you have a day off or a party day, let's call it, you are doomed. No, you can get the benefit even if, once a week or once a month, you have a party day. So I think that people need to understand that. You don't have to be religious about that. But definitely there are a lot of benefit of caloric restriction or intermittent fasting.
Yeah. So as far as like with some of the markers that you guys assess, like curious to know, like, have you had individuals that have, they've never fasted before, then they've got some lab work done, and then they've decided, I'm going to undergo some fasting? Like, what are some of the outcomes you've seen with some of these patients?
Yeah, definitely. And actually, if people are interested, they can go to InsideTracker.com, and there's some blog. We had a data scientist that done like 5-day fasting, and another product manager that done, 7 days fasting. And it was fascinating to see the level of the markers. So as I said, you can see what I mentioned. You can see the metabolic related marker going much lower. So you can see the LDL and the glucose and other markers. So you can definitely see that. You can... it's really interesting to see, at least in the people that we looked at that. And again, it's an N of 1. So we haven't done a full study on that, on caloric restriction. But there are studies that the USDA done a study, multi-center study on human for a couple of years with caloric restriction. It's very hard in human to decrease the calories by 30 to 50% because you cannot control us. We are not in a cage and our refrigerator is, 5 meters away from us. So it's very hard to do it. But I think that if I recall correctly, they decreased the amount of calories by around 15%. And they still see a positive effect on the metabolic related markers and the blood pressure. Yeah.
So as far as like some of the other interventions, Gil, can we sort of explore, like, I know we just sort of spoke about the caloric restriction side. What about like the specific macronutrient manipulation? So for example, adjusting, going lower on protein or higher on protein, lower on fat. What sort of studies have been done there?
Yeah, so that's not something that I'm an expert in or something that we are recommending. What we are recommending in our mantra is, if you are talking maybe about keto diet and the high fat and the high protein and all of that, that's not something that we are recommending. We are not recommending normal people to go to the extreme. What we are trying to do, our mantra is, let's understand your body and see what are the deficiencies that you have or what you have too much, and then let's adjust it and optimize your body. I can tell you that there is a lot of data about, let's say, other less extreme diet, and I can talk about them, like Mediterranean diet or vegan diet or veggie diet, that show a lot of benefit of them. Again, related to metabolic related markers and all-cause mortality and also diseases. But you need to remember that if you go for a veggie or specifically vegan diet, you have other side effects that you need to take into account, because you most likely will have low iron and low B12. So in that case, you need to measure and then adjust it either by acquiring those nutrients from plant-based food or supplement with that.
So as far as like InsideTracker, Gil, I'd love to learn more about like maybe in the last couple of years, like how it's evolved and like maybe some of the new features and tools that you offer the patients.
Yeah, sure. So first, we don't have a patient, we have users. Our customers are all healthy. We are not dealing with anyone that is sick, and our goal is to keep you healthy. And if you are sick, you should go to your physician. But what we had in the last couple of years is, as I said, we started with the blood biomarkers. We are adding all the time more and more markers to capture more and more a picture of your body. And in the last few years, we also add the data from your DNA and basically overlay the DNA on the blood biomarker. So for example, not only that you have high glucose, but also whether you have high risk for high glucose. Or not only that you have high cholesterol, but also do you have a high risk for high cholesterol. Or whether you are more fit for endurance versus strength, or vice versa. Whether you might have a high chance to be sensitive to nuts or sensitive to gluten and so on. So we are using the DNA to support the data from the blood. And more recently, we had the data from a fitness tracker, such as resting heart rate and deep sleep and REM sleep and total sleep. And now we are working to add VO2 max and HRV and other to basically allow us to understand what's happening in your body right now based on physiology. So all of that together allow us to receive a high definition or maybe even 4K definition of your body, understand your body very well, and then giving you a better recommendation, because I'm sure that you heard the term garbage in, garbage out. So if we have a better information about your body, we can give you a better recommendations.
Yeah. What about as far as, I know the microbiome is definitely an area that's of interest lately. Do you guys have any plans in terms of assessing things in relation to the microbiome?
Yeah, absolutely. Currently, there is not enough data to give a consumer a recommendation about microbiome other than what is the diversity of the bacteria. Do you have high diversity or low diversity? But we are monitoring the literature very closely, and I'm starting to see a few sprouts of information that might be interesting. So we are looking into that, and I assume that in the next couple of years or so, we will add microbiome, and we'll do it again when we'll be ready. I can tell you that we added the DNA a few years ago, only after we have seen that there is enough information that we can use. Because I don't want to charge you a lot of money and then give you a low value. So we want to do it when the value will be there.
Yeah. As far as some of the DNA data, let's say, for example, maybe somebody is at risk for type 2 diabetes, like, is that drawing upon numerous genes that support that? Like, how do you establish that?
Yeah. So we'll need to dive a bit into the genetics. So what we are doing, we are looking at an array, microarray, that has around 850,000 different single nucleotide polymorphism. So basically, what does it mean? That one nucleotide, so the DNA is built from nucleic acid, A, G, C, and T, and they are basically double strand. And a lot of the difference between you, Lucas, and Gil are basically single nucleotide polymorphism, meaning that I have C here and you have T, or I have A and you have G, or whatever. So those single nucleotide polymorphism are located on this array, and then we can find and see what are the difference in Lucas comparing, let's say, to a model person. And then there is a data in the literature that say that if you have this single nucleotide polymorphism, you have a slightly higher risk, let's say, to have high glucose. But what the scientific community developed in the last few years is what I call a score. So basically, you look at tens or hundreds or thousands of those single nucleotide polymorphism, and then based on that, you can come and find what is the risk score for Lucas to have high glucose. Is it very high, very low? And we can even give you a score between 0 to 100, okay? So that score, it's pretty good. You need to remember that genetics, it's a risk score. Yeah. The fact that you have a genetic predisposition to high glucose doesn't mean that you have a higher glucose today. It says that you have a risk. And if you look at that, basically how much it's explained in a normal person, you can see that it's usually up to 10%. So actually the majority of the cause of whether you have high glucose or high cholesterol or high are controlled by you, by your nutrition, by the environment, by your lifestyle. So even if you have high risk for something in the lifestyle related, you have a lot of control in your body. So a lot of people say, oh, it's my genetic, I cannot do anything. And that's wrong. You can do a lot. Maybe you need to work harder because you have predisposition for that. But you can do that. And I like the analogy of going to the casino and playing, let's say, poker, okay? So you don't control what card you receive when you play poker, but you can control how you play the card. So the genetic are the card that you receive, the lifestyle, the nutrition, the exercise, the supplementation, it's how you play the card. So if you play the card well, even if you had a bad card, you can win. So it's exactly like that. The genetic, it's good to know the genetics, but then when you know that, maybe you need to work harder. That's okay. Work harder and beat your potential.
Essentially epigenetics, right? Like that's based upon that term.
Yeah, so epigenetic is something else. We can actually get into that. And that's another very exciting part of genetics. So epigenetics, just to explain to your audience, are modification on top of the genes. A very common one is methylation. So there is what we call CPG island, which mean a C, phosphate, and G. And those sequences are usually methylated. And the amount of methylation of those locations can signal to some enzyme in the body whether you can transcribe the gene and then express it or do some other activity in the body. What is interesting that the methylation can, or the epigenetic can control a lot of processes, and there are also correlation for disease, but also for longevity. So I would say around 10 years ago, a scientist in UCLA, his name is Steve Horvath, looked at the epigenetics and tried to find a correlation between the methylation of your genome and your age. And he found basically using statistical analysis or machine learning, he found that there is a very strong correlation between a few hundreds methylation site or epigenetic site and the age. So he can predict very nicely without seeing you. Lucas, he can look at it and come and say, hey, you are this age. And it's very, very statistical, it's very, very strong. Wow. So that's what is called epigenetic clock. Okay. Now, that was the third generation clock that was trained only by age. Now there are other clocks that train based on disease and longevity and other. One of them called Grim Age, basically try to predict when you will die and stuff like that. So those clocks are very interesting. And it's another thing that actually we are looking at to add to InsideTracker. The issue with those clocks today is that they are not lifestyle responsive, right. Meaning, yeah, you will know that, I don't know, let's say that you are, 25 and your epigenetic age is 30. It's very hard for you to modify it. So we are now working on building a clock that is lifestyle responsive. That, okay, if you lead the right diet, or if you will exercise the right exercise, or if you will change your sleep habit or the lifestyle habit, you can modify your clock. So it's something that we are working on. But in the meantime, we develop a clock based on blood biomarkers. So we have what we call inner age, which is basically biological age, that based on around 15 blood biomarkers, we can tell you how old you are internally and compare it to your chronological age, and also tell you what is the influence of each biomarker. So we can tell you, hey, your glucose make you 1.5 years older, but your LDL cholesterol make you 1.5 years younger, and vitamin D make you 1.5 years younger, and so on. And then you can focus on the markers that make you older and will give you a specific intervention. And then you can do the inner age again. And because the blood is changing and very plastic, you can modulate your inner age and make it younger if you work hard. Wow. So that's something very cool that we developed. We developed it actually in 2015 together with Lenny Guarente, which is the professor that I done the postdoc at MIT, and David Sinclair. So we developed it then, and now we have the second generation, because when we developed it at that time, we had a very small database. Now we have a much bigger database. So we develop it based on our database. And it's a very exciting solution because what is nice about it is give you one number and everyone knows his age and everyone remember what is his inner age. And then you compare all that to say, oh, I'm older, so I need to work hard on that and that and that. It's give you a lot of motivation to try to beat your chronological age or even become the youngest as possible.
Yeah, awesome. So what about as far as like the integration into some of the, I know that you've recently added integration to like different smart devices, Apple Watches. Do you want to sort of expand upon that?
Yeah, of course. So as I discussed before, we believe that physiological markers are important. And why it's important? The quality of the data from physiological markers is lower than the blood because it's not a grade of a physician. Physicians usually are not looking at your resting heart rate and deep sleep and REM sleep. They will come to there, but we don't have enough scientific literature for that. But what is nice about it, that the frequency of the data is much higher. So if we are looking at DNA, it's a once in a lifetime because your DNA is stable. And let's say blood biomarker, if you are very engaged, you'll do it every quarter. The physiological marker data come every day. If you have a Fitbit or Garmin or Apple Watch or other, you can receive the data every day. So because you receive it every day, you can get that data and we can give you some explanation about it. And it can be also a proxy for some blood biomarkers. For example, there is a correlation between the resting heart rate and your iron markers, okay?
Is the correlation there, Gil, like low iron would indicate like
higher resting heart rate.
Yeah.
Or if you look at HRV, so it's related to stress or cortisol. So I think that it's not a thing. It can give us a lot of proxy for our blood biomarkers. And also it will make a user more engaged, because I see the process of user is coming, getting blood test, and that's an amazing experience. You get a lot of information, the quality, the amount of information, what you need to read, what you need to understand. You basically discover your body from the inside. So I see it as a mountain. It's a big mountain. It's a lot of information, a lot of excitement. I know that the week before I'm getting tested, I eat well, I sleep well, I'm trying to, it's like before you get your yearly picture for your, I don't know, in the college or in high school, you try to be the best that you can. But then you have valley, because again, you cannot do it every day. So what is nice about all the physiological mountains, it can be the hills between, because then we can come tell you, hey, you haven't slept well last night, but that's okay. If you'll do X, Y, and Z today, you might improve your deep sleep or REM sleep or whatever. Or we can tell you, because we have the data from the fitness tracker, we know that you finish an exercise. So we can tell you, hey, Lucas, you finish a 1 hour run, and now you need to replenish your liquid, or you need to replenish the protein. So we develop an algorithm that will tell you exactly, based on your age and gender and the activity that you've done and all of that, what do you need to drink? How much you need to drink? What do you need to eat? How much you need to drink? What is the window that you should do it? I think that there is a lot of confusion right now for an average person to understand what to do, and we are giving them a tool to do that. So we develop a lot of small mini application like that give you a value between the mountains of the blood test. So that's how we use the data from the fitness trackers.
Yeah. Now, I know before you mentioned that you're waiting for stronger data to come out in the field of like the microbiome. What does the future look like for InsideTracker? Do you have any other big plans, like ideas in mind?
Yeah, definitely. So as you mentioned, we are looking into adding the microbiome. We are actively working on building a lifestyle responsive epigenetic clock, which we discussed before. We are also looking into integration of continuous glucose monitoring. That I'm sure that you and your audience heard about it. Today, there are some direct-to-consumer solutions, but there is, looking at that is like having a horse with a blinder, because you look at one biomarker in a separation. So maybe when I eat oatmeal, my post-meal glucose peak is higher, but maybe it's good for my LDL, or maybe it's good. So we are trying to combine it together with the blood. Again, the blood is the liquid gold, and give you a better assessment of your body. And it's great that you have a continuous glucose monitoring. Actually, the vendors that build the continuous glucose monitoring are now building a continuous keto monitoring. So I think that even in a few months, you will start having a continuous keto bodies monitoring.
Oh, keto, yeah. Okay. Ketones, okay.
Ketones, and there will be other. Some companies are looking at continuous triglyceride monitoring. So I think that all of that can be very cool. Some saying that maybe Apple is trying to do continuous glucose monitoring using the Apple Watch. So there will be a lot of interesting. I don't believe it, because it will be very hard, and I'm not sure that it will be accurate, but there are some rumors about that. So I think that there is a lot of excitement about that, but that's the inputs. Yeah. What I'm really working on right now is what I described before, the hills between the mountains. So data from a fitness tracker, but also it's very easy right now for us to record the activity that you've done. You have a Fitbit, Garmin, Apple Watch, Oura Ring, whatever, Whoop, and you know exactly what you've done. But it's very hard to know what you enter into your body. Like nutrition is hard. Let me give you an example. Average person spend maybe 200 different decisions a day about nutrition. What should I eat? When should I eat? How much should I eat? And all of that. That's that's the hardest problem. So we are trying to work on a solution to allow us at least to maybe understand you for a week. So to do a recall for a week, every quarter, let's say. And during that recall, we have a very good technology that you basically can use your phone, scan the food, and it will recognize exactly what you ate. Then we know what you ate, when you ate it, what is the amount that you ate. And then we can understand you better, because usually what you eat in a week is, I would say, 90% cover what you eat in the other week. And then we can start giving you some correction. Let me give you an example. We can even build a heat map and say, hey, Lucas, every time that you are in this area, let's say that this area is the area of pubs that you like to go, that's not a good area for you. Give you an alarm sound. Stay away from that area. That's a bad area for you. Or another area that, I don't know, the park that you are used to run, that's a great area. Will give you a nice music that will make you happy. So stuff like that to allow you to understand yourself. And then, for example, when you go into a restaurant, because we know so much about your blood biomarkers and what you do and what you exercise, we can tell you, hey, Lucas, we realized that you went to restaurant X. The best food in this restaurant for you is this dish. The second best is this dish. The third best is this dish. Yeah. Then it's your decision to make. So giving you a lot of tools to allow you to live better, longer life. That's basically the vision of InsideTracker.
Yeah. I'm so glad you mentioned like with the glucose monitor, and you said it's very like hyper fixated on just one metric or one marker. I said the exact same thing because I love experimenting. I've gone through like 3 CGM devices. And I became to hyperfixate on just glucose when it was like, if we were to check that meal, the post-meal, what about triglycerides? What about insulin? What about glucagon? What about all these other hormones that matter? I think that's a really good point. But as far as the future we've just sort of mentioned like future plans for InsideTracker. It does sound really amazing. If my listeners want to learn more about InsideTracker, where can they go to like learn more about it?
Yeah, so they definitely can go to InsideTracker.com and learn more. We are also on social, Instagram, Facebook, Twitter, and so on. So I think that it's pretty easy to go there and learn more. One point that I wanted to say is that when I started with my fascination for longevity. So we started recently a podcast about longevity. We call it Longevity by Design, and we interviewed already around 15 leaders in the longevity field, David Sinclair and a lot of other, Andrew Huberman, if you heard about him. But a lot of other scientists, very good scientists that maybe they are not as known as David Sinclair, but they are doing a very good job in studying longevity. And that's another place that if someone is excited about longevity, they can come and visit our podcast. We are releasing podcasts every other week, and we have a lot of very interesting guests that have already been out, but a lot that are going to be out soon. So that's another place to learn more about, not InsideTracker, but about longevity and my passion of longevity.
Great. I'll make sure to leave those linked in the show notes for my listeners. But otherwise, Gil, thank you so much for coming on the show. It's been an absolute pleasure having you on.
Thank you so much, Lucas. That was a pleasure, and continue to do the amazing job that you're doing.
Thank you. You too.
Thank you.